Okay, let's look at another example, solving for concentrations using an equilibrium table. So this is a different example where we do have an initial concentration of products at the beginning of the reaction. So I'm just going to write out the formula. So the formula is hydrogen gas plus fluorine gas is in equilibrium with hydrogen fluoride gas. Again, you always need to make sure that the formula is balanced. Now it is. And we're told in the problem that the Kc of this reaction is 115. Okay, so here's the question. It says 3 moles of each species is put in a 1.5 liter vessel. What is the equilibrium concentration of each species? So like I've been saying, that usually when we start, here's the reaction, initial, change, equilibrium. Usually we start with some known concentration of the reactants, but we don't start a reaction with any of the products. Well, this problem is different because it says that we're starting with 3 moles of each species. So that means 3 moles of hydrogen, 3 moles of fluorine, and 3 moles of hydrogen fluoride. So you can always assume that there is no product at the beginning of the reaction unless it says otherwise. Also, remember everything that goes in the equilibrium table is a concentration. So this is 3 moles in a 1.5 liter container, which gives us a molarity with the correct significant figures here of 2.00 molar. This should have been 3.00. That should have been 1.50. 2.00 molar. So that's what's going to go in my initial column. 2.00, 2.00, 2.00. So again, what's different about this problem is that we do start with an initial concentration of the product. So this is unique, different than the other ones. You just have to kind of read the problem to see which of these techniques we're going to use. We're using the equilibrium table for all of them, but they all have a little bit different information. Okay, so now I'm just going to fill in the rest of the equilibrium table. So it says, these are the initial concentrations. This is the Kc, so I want to know what are the equilibrium concentrations of each species. So I want to know what is the equilibrium concentration of hydrogen at equilibrium, fluorine at equilibrium, and hydrogen fluoride at equilibrium, which is going to be this row of my table. So whatever I get for this row, I'm going to then use to solve for these equilibrium concentrations. That's what E stands for. Okay, so here, this is changing by minus x plus 2x, don't forget that coefficient. So this is going to be 2.00 minus x, 2.00 minus x, 2.00 plus 2x. So now I'm going to use this equilibrium row and the Kc to solve for x. Because remember, the Kc equals the concentration of the products over the concentration of the reactants at equilibrium. So let's rewrite this over here, Kc, I'm just going to write this out with the compounds and then we'll plug the values in, is going to be the concentration of the hydrogen fluoride squared over the concentration of the hydrogen gas times the concentration of the fluorine gas. So now let's plug in what we know. So it's 115 is the Kc equals the equilibrium concentration of hydrogen fluoride 2.00 plus 2x squared over 2.00 minus x times 2.00 minus x. So here we are, we need to solve for x. So what you should recognize here is that 2.00 minus x times 2.00 minus x, this is the same thing as saying 2.00 minus x squared. So now this should look familiar as a perfect square where I have squared on the top and the bottom. So now I can solve by taking the square root of both sides to solve for x, and I don't have to use the quadratic formula. So that's what I'm going to do. I take the square root of this side, square root of this side. So when I take the square root of 115, I get, I'm going to move this over here a little bit. So it's going to be 10.72 equals 2.00 plus 2x over 2.00 minus x. So now I'm going to multiply both sides by 2.00 minus x. And then I'm going to move this over here and the x over here. So minus 2.00 minus 2.00 plus 10.72x plus 10.72x. So when you do this, you should get 19.44 equals 12.72x. Divide both sides by 12.72. And you should get x equals 1.53. This x is what we are going to plug back in up here to solve for these molar concentrations. So that's what I'm going to write down here. The concentration of hydrogen is going to be 2.00 minus x, 1.53, which is going to be 0.472 molar. That's the concentration of hydrogen. Same for fluorine. 2.00 minus x is going to be 0.472 molar. And then hydrogen fluoride, 2.00 plus 2x is going to be 5.06 molar. The question said, what is the equilibrium concentration of each species? Here are the equilibrium concentrations of each species. So another example of using an equilibrium table to solve for equilibrium concentrations. This one was a little different because we did have an initial concentration of the product. We were able to see that this was a perfect square, so we could take the square root of both sides and be able to solve for x without using the quadratic formula.